Welcome to Online Lecture 6 on heteroatom groups. Here are the topics we're going to go over in today's lecture. So we're going to start by talking about some of the main functional groups that you can see on an organic molecule, because some organic molecules have functional groups that influence the overall properties of the molecule, and so we give them priority in the name of the molecule. So the dominant group in a molecule is going to influence what the root of the name is. And so when we're prioritizing groups, we have a set list of highest to lowest priority. So the highest priority group that we're going to go over today are the ketone groups, and that's anything with that C double bond O surrounded by a carbon chain. And then we're going to go over alcohols, and finally amines. Amines are going to be the lowest priority group out of all of them. So I'm going to go over alcohols first because they're the simplest group, and I'm going to just go right into the examples. So first of all, I'm going to start with the examples on the bottom since they're simpler. So the way that we name the root of an alcohol molecule is we just add the suffix OL, all. So in the example here, if we're naming this first example, we're going to number the carbon chain 1, 2, 3, 4, like that, like we normally would. And then to name it, instead of making the OH a prefix, because it's a functional group, we're going to make it the suffix, the OL. So we call it butan for 4, 2-all, because it's a butane backbone with an alcohol on position 2, like that. So for the next one, 1, 2, 3, 4. And so this one will be named butan 1-all, because the alcohol is now on position 1. And for this cyclopropane, I can actually just call that cyclopropanol. And that's because the OH is always going to be position 1 in a ring, so I don't have to specify its position 1. So now let me go to the more complicated situation. The OH in a ring is going to be position 1 because it takes priority over any other group. So this is going to be 1. And then thinking back, when we have double bonds on a backbone, those take priority over any other substituent, and so we're going to number this way, like that. And now naming it, the chlorines, which are going to be substituents, are prefixes, so they're actually going to come first. So the beginning will be 6,6-dichloro. Okay. And then the backbone is a cyclohexene because it's got double bonds. So we have cyclo, hex, and this is where we look at the position of the double bonds. It's on 2 and 4. So we say 2,4-diene because there are 2 double bonds. And then all is going to be the suffix. And so we say all, like that. And finally, if we ever have alcohols not being the highest priority group, because remember ketones are higher priority, then it becomes a prefix. And alcohols as a prefix are called hydroxy. Next, we're going to talk about amines, which are the lowest priority group. So I'm just going to go straight into some examples. So for the first example, amine is still the higher priority over normal substituents. So in this case, we're going to number from left to right, like that. And the name of this molecule will be 4,4-dichloro. And then it's a butane molecule, so butane, and now the amine is on 2, amine, like that. Okay, let's look at the next one. So in this case, the longest carbon chain with the amine group on it is actually 1, 2, like that. So this methoxy is a substituent. And so that's going to be in the very beginning of the name. 2-methoxy F-N-1-amine. Because the amine group is on carbon 1. Now, again, when you have a cyclohexane or any cyclic ring, your functional group is always going to be the first number, so you don't actually have to include the number in the name. So we're going to number it that way. So this will be called 3,4-diethyl. And then we have a cyclohexane, so cyclohexanamine, because we know the amine is on carbon 1. So let's talk a little more about how we name amines. When an amine has more than one chain attached, meaning that instead of an NH2, now you have other carbon groups attached at the nitrogen, you're looking for the longest chain attached to that nitrogen. And so any other group attached to the nitrogen is considered a substituent. And the location of that substituent is said to be on index N. So it'll help to do some examples of that. So let's try with this first one here. So in this case, the longest chain attached at the nitrogen is the ring, going this way. And so to name it, the other two methyls coming off of that nitrogen are substituents, and so we would have to call it N,N-dimethyl, because they're two substituents located on N. And then the root is going to be cyclo-hex-2-ene, because there's a double bond on carbon 2, and then amine. Again, the amine has to be on position 1 in a ring, so you don't need to add it. Okay, now for the next one, there's 3 identical groups attached to the nitrogen, so you don't necessarily have to pick, just one of them is going to be the root and the other ones are going to be substituents. And so in this case, we have N,N-dipropyl and 1-amine. In this case, it's a chain, so you do have to say that it's attached on carbon 1, like that. Now for this last example, which is the most complicated, the longest chain is the one coming off this side. And in this case, we have to make sure it includes the triple bond, so it's going to go that way. Okay? And so now we have 3 substituents. We have 2 ethyls, one attached at the nitrogen here, one here, and we have the chlorine. Chlorine is first alphabetically, so that's going to be the first group in the name. So we're going to call it 3-chloro, like that. And then we have 2 ethyls, N,2-diethyl. There you go. And now the root of the name is 5 carbons long, so it's pent-ine, and it's on carbon 4. And the amine is on carbon 1, so pent-ine 1-amine, like that. You don't have to name the hydrogen attached. It's assumed that if there aren't enough substituents attached to the nitrogen, then anything else is a hydrogen. So in this case, there was 1 substituent on the N and the root, and so there was one other hydrogen attached, and that's just known. So with an amine, the root is going to have a suffix amine, as I've shown, if that's not the highest priority group, which it often isn't. If there's another priority group on there, we use amino as a prefix. And finally, the last group we're going to go over today are ketones. Ketones have suffix -one, not one, we pronounce it -one. And if it's a prefix, if there are higher priority groups, which today we aren't going over anything higher priority than ketone, we would use oxo as the prefix. So let's just dive straight in. So in this first example here, we have the backbone being the largest chain that has both of the high priority groups on it. So since there are two ketones, we want to make sure that they're both on the longest chain. So I'm going to start my numbering here to make sure that the amine is in the lowest possible number, and everything else is just a substituent. So to name it, the first group is amine because that is now a substituent, and so I call it 1-amino. In alphabetical order, the next thing is the propyl, and that's on carbon 3. And then the backbone is a pentane, so pent, and because there are two ketones, we will call this 2,4-dione, like that. Now for the next example, when we have a cyclohexane, we start the numbering on the priority group. So that will be here, and then we're going to count around like that. And so to name it, first we start with the substituent, which is this, a methoxy, on carbon 3. And next we call it cyclohexane because it's got a double bond on carbon 3. And then finally it is an -one, but because it's on carbon 1, I don't have to put that, so it's just -one. Like that. And so finally, let's just go over a couple more examples where we have multiple different functional groups on the molecule. So for this first one, if we want to put the highest priority group, which are the ketones, at the lowest index, we're going to start the numbering here, left to right. And then keep going down the triple bond like that. So to name it, there's only one substituent, and that's the amine, so it's 6-amino, because amines are the lowest priority group. And now because it's an 8-carbon chain, I'm going to call it oct-7-ine for the triple bond. And now because there are two ketones, I'm going to call it 2,4-dione. Like that. And now finally, for the last example, the ketone is the higher priority out of all these groups. It goes ketones, then alcohols, then amines. So in this case, the ketone will be carbon 1. And then to number it, both alcohols are second priority, but to make the numbers work, I'm going to start numbering in this direction, like so. So both the alcohols and the amine are now substituents. The amines is called amino, and the alcohols are called hydroxy as substituents. So amino is first alphabetically, 4-amino. And then we have the alcohols, which are 2,5-hydroxy. And then the root is a cyclohexane. So cyclohexane. And that's it.